on every S2 paper you're expecting there to be two types of continuous random variable question, the general one and the rectangular distribution one. And this question is kind enough to warn us this is a rectangular distribution. Write down means it's going to be easy, the expectation for 1 mark. Don't use any integration. On page 11, towards the bottom you've got the table which has the formulas for expectations and variances. Just apply the one for the rectangular distribution for 1 easy mark. Then we've got to prove using integration. So although we could use the other formula from that table, we actually have to set up the integration. It's the top of page 11 where the integration formula is. It's not just an integral, it's an integral minus something squared. Make sure you don't forget that last part. And you have an example in your notes of how to derive it for the general case when it's from A to B instead of from 0 to B. This one's significantly easier, but following the example in your notes should help if you're stuck. Then in part B, we're continuing with rectangular distributions. It's not really directly related to A because it doesn't start from 0. But we simply have to get a single probability from a rectangular distribution, and you're always best by sketching it. So we've got some kind of rectangle. There's the x-axis, I won't put the y-axis on. And we've got to find the probability the modulus of t is greater than 0.02. So positive values greater than 0.02 will be okay, but so will some negative values. And if on your sketch you shade the regions that you're interested in and directly work out the area of a rectangle, you should have no difficulty working out this dimension here. The table on page 11 will help if you really need it to. Work out some suitable areas, add them up, and that should be your 3 marks.